Okay, good morning. Welcome to
FamilyMath 425.
425. So yesterday, and I'm going to zoom in on this, so you guys are going to go out of the shot, but try to hold it steady and just have it spin just gently, real gently spinning. What is this shape that we built yesterday?
It's all the platonic solids inside of one another.
Okay, let's start from the inside and go. So what's on the inside?
An icosahedron.
Okay, and that's got what faces?
Triangle faces.
Okay, can you spin it just a little more? A little more. There we go. Triangle faces. Okay, and what surrounds the icosahedron?
The octahedron.
Octahedron.
8 triangles.
Okay, and what's around that?
And then
Tetrahedron.
Tetrahedron, and those are both green.
Triangles.
And then
Spin it just a little more. Just a little bit more. A little more. There you go.
And then
Maybe
a
cube.
cube.
A cube.
And then the dodecahedron.
Then a dodecahedron. And all right, you can. I'm going to zoom out now. You can put it down on the ground. Can one of you, whoever wants to go first, tell me some things you think about when you see this shape.
Well, I kind of think it's kind of weirdly symmetrical because there's like this icosahedron line has this thing coming down in the center, and I think this point is on the line.
Interesting. Okay, so there's a lot of symmetry.
And here it's interesting how the scaling works because the icosahedron is not much smaller than the octahedron, but then the tetrahedron is really much bigger than the octahedron.
Okay.
And then the cube is a lot bigger than the tetrahedron.
Mm-hmm.
And the dodecahedron is not much bigger than the cube.
Yeah, that actually is very
So-
interesting.
It is twice the volume of the cube.
What is?
The dodecahedron.
Is twice the volume of the cube?
Yeah.
How do you know that?
Well, because we've done a project a while ago on a cube that can fold into a dodecahedron and back.
Okay.
So,
Yeah, I don't know. I'm not sure if it's twice the volume or not. It definitely is the case, and that's what we're going to look at next. That the
it's
dodecahedron
close.
can fold into a cube, but there's a gap in the middle.
So it's close to twice the volume, but not exactly.
Yeah, we might be able to explore what the relationship is. Okay, so previously we did a. Can you get the big shape out of the way now? Previously we did a project about folding a dodecahedron into a cube. So we got our cube and we got the bits here that are the tops of the dodecahedron, but instead you put them on the inside. And what we found when we did that project is we found that there was, when you connect it up, what are the orange balls now? And I'll zoom in a little bit.
They form an icosahedron.
They form an icosahedron. So here we have a separate shape that with a dodecahedron on the outside and an icosahedron on the inside, and we're going to try to figure out if it's the same icosahedron.
It might be.
What do you think? Do you think it's going to be the same?
I think it's not going to be the same.
You think it's not going to be the same? What do you think?
I think it is going to be the same.
Okay. Yeah, I really don't know. I'm super curious to see if it is. So what we're going to do is we're going to build it, and then we'll take a look, and then after that we'll connect up the orange balls. Okay.